So in this video, I am going to explain what is the Fibonacci series, how to generate the Fibonacci series. I know this is very basic things, but let me explain in the three different way. We will use first the sample approach, then the recursive approach, and then the dynamic programming to generate the different Fibonacci series. But first and foremost, what is the Fibonacci numbers, right? So by default, the first Fibonacci numbers is the 0 and then 1. These are the first two Fibonacci series number. Then what you have to do, you have to add these two number. So last two number you have to add. So 0 and 1 is the 0. Now you have to add these two number. 1, 1 is 2. Then now these two number. 2, 1, 3. Then 3, 2, 5. Then you can go the 8. Then 13. Then 21. Then 34. Right? So if you see that actually for this number, this is addition of these two number, right? For these two number, this is addition of two number. For these two addition, this is the two number, right? So this is how we are getting the Fibonacci. If you add these two number, this is this one, right? So if you see, this is the first 0 Fibonacci series number. So when I say the Fibonacci of the 0 is the 1, this is the first. This is the Fibonacci 2 and this is the Fibonacci 3, and same this is the Fibonacci 0, 1, 2, 3, 4, 5, 6, 7th, you can say the 8th Fibonacci series, this is the 9th Fibonacci series, or you can represent the F7 and you can represent the F8, you can represent the F9. So this is the Fibonacci series. So how to generate the Fibonacci series? It's very easy. So starting, what you have to do, you have to take one variable int and give the first two Fibonacci series, two Fibonacci number, and then you can print A and B both, and then what you have to do, you make the third one C, and C make the A plus B. So what is it become the C now? Sorry, not 0, 0 and 1, right? 0 and first two we have to take it, this one, this one. So C is equal to A plus B. So what is in the C? 0 and 1. So this is the 1. So you will get the this next one. And then what you have to do, once you got this one, then you move B value to A. So right now, what is in the B? 1. You move this B to A. And in the B, move the C part. So what is in the C? 1. So it becomes the 1. And you make this, and you can simple, if you want to print or something, if you want to print, you can print the C value, right? And so now C will print the 1. And you make this in the while loop. This will be continue. Till what time it will continue? So suppose if you want to take the till 8 or till 9. So you can pass the n. So suppose if you pass the n 8, means you want to get the Fibonacci series of 8th one, or you want to make the value of the F8. So what you have to do, make one counter, make one counter here, and anyhow you have to already print the 2, so start the counter 2, and in the while loop you have to run this program till counter less than equal to n, because I want to go n. And then finally, whether you want to print or n or not, finally your the last number is in the C, so return the C. This is how you can get this. Let me again explain you. By default, 0 and 1 take into the A and B variable, make one counter, so you can count how many positions Fibonacci series you want to return or you want to generate, and then make the C is equal to A plus B. So this is, if this is the A, if this is the A, this is the B, make the C, right? C is equal to always A plus B. Once you get the C, make the counter increment here. So every time you have to make the counter increment. Again, next time whatever do, you make this A, you make this B, again here C is equal to A plus B. So this way you have to move and you will get this number, right? Let me show in the code. So as we discuss in that, take one variable A, keep the value 0, and second Fibonacci, take the 1, right? And take the C, keep the 0, and take also the counter, right? So we have already defined the two, 1, 0 and 1, so counter, keep the counter at the 2, right? And now if we will check, our counter should equal to the n, and when you come inside, so add the 2, and as we discussed that we have to switch the number, right? So now B should be assigned into the A, and in the B we will assign the C and make the counter increment, right? Let me check whether it's working fine or not. It should work, I think. Yeah, it is accepted, right? So this is how we can if you see this, if you can change the number, so we can, if suppose if you want to give the n is equal to 8, right? And you know at the 8 21 should become, right? Now check 21 is coming or not. Yeah, 21 is coming. Let me see the next approach on the whiteboard, that is the recursive way. So that was the sample approach. Now you go for the recursive. So if you see here, f0 is equal to 0, right? In this, according to this one, f1 is equal to 1. But if you see f2 is equal to the addition of the f0 and f1, right? The same thing I am saying, this is for the previous two one, right? So f2 is this one, it is addition of the previous last two. Again if you see, f3 is the f2 plus f1, right? So if you want to check, we can check f3, this one, the value is 2. How you got the 2? f2 and f1. So f2 is the 1 and the f1 is the 1. So 1 plus 1 is equal to 2. So we are getting that, right? So again if you go the continue, f4 is equal to f3 plus f2, right? Again if you want to see the f5, this is the f4 plus f3. And if you want to get the fn, so what you have to do, fn minus 1, because if you are taking the 5, it was 5 minus 1, 5 minus 2, right? This was the 5 minus 1, this was the 5 minus 2. Same way, if this was the 4 minus 1, this was the 4 minus 2. Same way, fn minus 1 and n minus 2. This is the approach. So if you see that at any positions we are doing the same thing, right? So this is very good suitable approach for the recursive. But let me show in the other different way. Suppose if you want to take the Fibonacci series 5. So if you want to take the 5 is the combination addition of 4 plus 3, right? If you see the Fibonacci 5, it is the addition of the 4 and the 3, right? 2 plus 3 is equal to 5. Again if you go the bifurcate for the 4, how you can take the 4? Fibonacci 3 and Fibonacci 2 if you add here, right? How to get the Fibonacci 3? Fibonacci 2 and Fibonacci 1. How you get the 2? Fibonacci 1 and Fibonacci 0. And we know already Fibonacci 1 is the value 1 and Fibonacci 0 is the 0, right? This is the way we can do that. So if you see, whatever the operation you are doing here, same operation we are doing at every places, each steps. So that's why this is the perfectly good for the recursion. So I will write one method and use the recursion and then it will work it, right? So how it will work? So simple, what I have to do, what we can do that, write one method, anything, Fabo, and pass the n, right? When you pass the n, and this is the, you can pass integer number, and then what you have to do, if n is equal to either 0 or 1, if n is less than equal n, so whatever the n, if this is the 0, you can see if f0 is 0, f1 is the 1, right? So same way, if this is 0 or 1, return the same n. Again, I am repeating it, f0 is the 0, right? So the same way, f1 is the 1. So for these two cases, whatever the value of n, we are returning the same, okay? If the n is 0, we are returning 0, f1 is 1, n is 1, returning the n, right? 1. So this is the condition. But if that is not the 0 and the 1, then we have to call this method again. If this is, suppose if this is the 3, so what you are doing that, if this is, you want to get the 3, what you are doing, we are calling the same Fibonacci with these two number, right? If this is the n, we are passing n minus 1 and n minus 2, and you are doing the addition here. The same thing you have to do for the Fabo n minus 1 plus Fabo n minus 2. That's it. This is the simple method. Whatever I explained, it was the simple method, and this is the recursive way. So because this doing the same thing, we can do the this method, and it will work. Let me show in the code, right? So in the recursive, what you have to discuss that. So just simple, if n value is less than equal 1, right? If this is the 1 or the 0, we have to return the same number, right? Otherwise, we have to return calling the same n minus 1 and plus n minus 2. This is very simple. So now it should work also. So this is the 2-line code. We are using the recursive here, and should fine. It is working fine, right? If you see given the 8, you are getting the n1. So this is a very simple, as we discussed on the whiteboard also. This is the recursive way. Okay, let me go to the whiteboard and understand the dynamic approach, right? So now we saw the two approach, simple approach and the recursive approach. Now let me see the dynamic approach. What is the dynamic programming? If you see here, now you showed you how to do the 4, right? If you do the 3, how you will do that? F2 and F1. For the F2 again, it is the F1 and the F0, right? If you see, we are doing the same thing many times. If you see here, 2, for the 1 we need again 1. For the 2, we are calculating the 2 it again. If you see the 2 here, again we are calculating. F3, we are again calculating the multiple times, right? If you see the bigger tree, we are calculating the same number 2-3 times, right? So if you see here, F3 is here also, F3 is here also, for the F2 it is here also, here also, here also. So why you doing the same calculation multiple times? So that's why you can use the dynamic programming. What we will do that, we will create one array, give any name, take any size according to your use case, according to your use case, dp is equal to new int 32. As per the given, you can see that this is our dp and this is the indexes, right? By default, you know that all the values become 0 when you initializing the any array, right? So whenever you do the calculation, keep those values in the dp. So next time what you will do, when you want to take the new calculation, first check in the dp. If it is not there, then you can calculate. If it is there, then no need to calculate. You can take the value from the dp itself. How we can do that? In the same case, what you have to do, So you have to just modify this here. What you have to modify here? This okay, but when you want to take the new number, check if that value is already there in the greater than 0, means if any value is more than 0, means that we have already calculated. If it is calculated, then return that number and no need to calculate. If it is not there, then calculate. How you can do that? dp n is equal to this one, and finally return the dpn, right? So let me again explain this part. So suppose I pass the 8 here and 8. So of course if the value is less than 0, 1, then return the null. I will not come in this point. I will come here dp 8. So suppose if this is the 8, take more 7 and the 8. Starting time that might be 0, of course 0. So it is not 0, it will not execute. So what I will do, I will call the same method with the 7 and the 6. So this time 7 will come here, right? And again they will check the 7 is also not empty, then again they will call the 6 and 5, and ultimately they will recursively they will come here and return. The moment they will go back in the recursive, we know you might have get all the values, so next time no need to call. If you want to visualize, you can visualize with this diagram, right? So suppose if you have already calculated the 3, next time I will not calculate the 3 because this number is already saved in the dp3. So next time whenever the 3 will come, we will not calculate, we will take the value from the dp. So let me show in the code this part also. Okay, so now let me see the dynamic approach. So we are just going to change this recursive into the dynamic. How we can do that? Make one dp int dp, and let me take the size according to the question. Size is saying it will go maximum 30, right? So make 31 size here, safer side, and here what you have to do, check if dpn has already that number or not. If greater than 0, then return the same dp. We are not going to calculate anything. If it is not there, then in the dpn we will keep this value, that's it, and return the dpn. So that is for the dynamic, because we are storing the calculation to avoid the next same calculation the next time. Let me just run it. Perfectly fine. Let me submit the code also. Let me submit this dynamic code. It should work. It is accepted, right? So let me more advanced talk about the Fibonacci. Now this time we are talking about the Tribonacci series, not the Fibonacci series. So what is the Tribonacci series? So if you have seen that in the previous example, we are taking the last 2 and adding 1 here. But in this Tribonacci series, we will add the last 3. So first number is 0, means this is 0, this is 1, and sorry, this is the 1, and this is the 1, right? So when you generate for the third one, it will add all those 3. So 0, 0, 1, it becomes the 2, right? Now for this one, next one, for the F3, it will be the F0, F1 plus F2. So F0 is 1, 0, 1, 1. So it is the 2. So F3 is equal to 2, right? Now go for the F4. So if you go the 4, this is for the Fibonacci and this is for the Tribonacci, right? So now you take the F4 is equal to F3 plus F2 plus F1. So F3 is equal to, we have already calculated, this is the 2 and F2 is the 1 and this is 1. So it becomes the 4. So F4 becomes the 4, right? So means instead of taking the last 2, you have to take the last 3, and code is a very minimum changes, no need to do any much thing. Only thing you have to add one more thing here, Fabo and -3. n minus, this is one change. Another change also, because now we have to consider for the 2 also, right? Starting we took only the 2 part, but if you see in the Tribonacci you are taking the 3 part, right? So in the case of here you have to add, if n is equal to 2, then you have to return 1. That we will see in the code, right? Why are you putting the extra condition here? Because it's taking the first 3, so first 3 you have to assign. So 0 and 1 we have already assigned in the Fibonacci. In Tribonacci we are going to add an additional thing, f2 minus 1. After onwards it will be working from the f n minus 1, n minus 2, n minus 3, right? So if you suppose if your n is the 3, so then 3 minus 1, it is the Fibonacci 2, 1 and the 0, and all the 3 value we have already assigned starting time, then it will work here, right? So let me make this code for the try Fibonacci. It's also as we discussed that, let me one dp, and dp size will be considered from the given example, the use case here. So if you see it is saying the 37, right? So make something more than 37 or 38, or make the 40 and do the same coding. So if n is less than equal 1, then return same n, and I add the one more condition, right? If n equal to 2, then return the 1, right? After that again we check if dp n has the value, then no need to do anything, return the same dp n, right? If it is not there dp n, then you have to again call the same method for the 3 times. One is the n minus 1, same n minus 2, and same n minus 3, and finally return the dpn. Let me check whether it's working or not. It should work because we have already derived 1 minute time, right? And now let me submit this code. It's accepted, right? Thank you very much. It is all about the Fibonacci things.